One of the most devastating typhoons that made landfall in the Philippines is Typhoon Odette. As shocking as this may seem, this is the current reality of the Philippines when it comes to typhoons. Now, the question in mind, why does this kind of damage still happen? Are there ways that these kinds of failure can still be mitigated? If we look at the typhoons from 2010 to 2021, we see that Typhoon Yolanda was reported to have the largest number of damaged houses. But when we look at the partially damaged houses, we can see that Typhoon Odette actually had twice the amount of Typhoon Yolanda. This occurred despite Typhoon Odette only having 260 kph while Typhoon Yolanda having 315 kph. We see that these damages are not just a result of a higher wind speed, but of other factors as well. This is why we need a systematic way to quantify the risk and potential losses to different types of buildings in the Philippines. In line with this, I would like to talk about the severe wind hazard and risk assessment for Cebu City. Its benefits are not only for Cebu, but later on will be for the whole Philippines. To quantify the risk or potential losses, we need three major components. These components were implemented as projects in this program. The first is the hazard, which gives us the wind speed intensity and was implemented by DOST Pag-asa. The vulnerability, which gives us the performance of the building as a function of wind speed, which was implemented by UPDIs. And the exposure is the number and types of buildings in a certain locality implemented by DOST PBOX. In this presentation, I would like to highlight the vulnerability project of the program, which were a list of key building topologies for the Philippines and their corresponding vulnerability curves. Now, why is it important to have our own set of Philippine key building topologies? Agencies in foreign countries such as FEMA have software called Jesus MH, which can estimate potential losses from the disaster. They make use of vulnerability curves for different types of key building topologies. A sample building topology S1 steel movement frame is shown in this figure. But are all those kinds of topologies applicable to Philippine setting? Look at these types of residential buildings in Cebu. We cannot come to that conclusion. Thus, we need to come up with our own key building topologies that we can use for a multi-hazard risk assessment framework for the Philippines. We proposed a kind of nomenclature to classify buildings in the Philippines that can be used for a multi-hazard risk assessment framework. Before, there were only earthquake-sensitive attributes that we used for UPDI's building topologies, but this project produced hazard-specific attributes so that we can now cater to the risk assessment of severe wind. Once we have key building topologies defined, we can develop their corresponding vulnerability and fragility curves to quantify the performances of these types of buildings against severe wind. We can develop them through computational, heuristic, and empirical methods. Through field surveys, laboratory experiments, numerous computer simulations, we are able to investigate damage. With all those results, we were able to develop multiple vulnerability and fragility curves for different key building topologies. Incorporating all these concepts into a risk assessment tool developed by Pag-asa, we can use the vulnerability curves to estimate the total physical damage for certain barangays in the Philippines, wherein the pilot study of this program was in Cebu. And using fragility curves, we can estimate the number of buildings in certain damaged states for different barangays in the Philippines. And subsequently, with the number of houses that are damaged, we can approximate the total population that is affected. To end, we currently have developed 35 key building topologies, 84 vulnerability curves, and 112 fragility curves. With availability of exposure data for different parts of the Philippines, this risk assessment methodology can be replicated for other parts of the Philippines. And all these things can be done to move towards a more resilient Philippines against severe wind.